All right, folks, we want to welcome everybody tonight. Hope you guys are fantastic all around Australia. This is our latest series where we've got Alistair from Barker, and he needs to smile. Hey, we can see you.
Hello.
How are you? There you are. He was like, you can't see me. Anyway, so Alistair from Team 4613 is here to talk to us about pneumatics. And this is an introduction, but it's an introduction that looks pretty serious because I saw all types of equipment flashing around as we were getting ready for the video. So we are really excited. Alistair, I'm just going to let you take it away and get started.
Okay, great. So this is just going to be a fairly brief introduction to pneumatics for the first robotics competition. We've been using pneumatics since 2015. Prior to that, in 2013, 2014, we used motors and the robots were a lot simpler. I'm going to go through, I'm going to show the advantages, the disadvantages, some of the ways that you can use pneumatics on your robot. And then go through and show you the parts and give you some tips and tricks on how you can enhance your pneumatic system to make it as good as it can be. So why use pneumatics? Pneumatics is a very good way of doing linear motion between 2 points. So it might not be suitable for something like a turret or like a shooter where you need to have something rotating, but for moving between 2 points, in and out, it is ideal. Another advantage is the weight that can be saved. Motors can quickly add up in weight. And although pneumatics has a fairly high initial weight due to the air compressor, there are actually ways to mitigate this, such as smaller, lighter components that you can use. So I wouldn't suggest using pneumatics for 1 or 2 applications on the robot. But if you're doing more than that, 3, 4, 5 applications on the robot, then it can be really valuable. And it's a really good way to simplify your robot, simplify your programming, simplify the weight. So a big advantage is that they can be stored indefinitely without damage. So think about an arm that you might have on your robot. Say you want to intake a ball and you've got maybe your bag motor or your sim motor on the end of the arm moving that out. The trouble is that for that arm to remain in position, that motor needs to be stalled, which means there's current flowing through that motor. That creates 2 issues. That can wear out the motor prematurely, it can burn, it can set on fire, but also it's a lot of additional parasitic current draw on your robot, and you might end up having problems like brownouts. Pneumatics are also quite resistant to impact in ranges of motion, especially if you get large ones. This one's a little bit small, but ones with larger rods are very stiff and they can be quite strong. You might have seen in 2019, some teams trying to use the pneumatics to climb onto the level 1 HAB platform. So some teams were just using a large rod or bore pneumatic cylinder, lifting themselves up and then actually placing a lot of their load on the end of the pneumatic cylinder. Although that's not ideal and can lead to failure, it just shows you how pneumatic cylinders, especially large ones, can be quite strong. They're also easier to mount than motors. If you've used gas springs or you see the boot of your car, you'll see that they just normally have a rod end at either end, and you can easily put a bolt through that. These are normally called a rod and a clevis. You can also get round ones with a little bearing on. So they are very easy to mount. For this one, you could just use an M4 and an M5 bolt straight through, very straightforward. And they're much simpler than using a rack and pinion or similar linear motion system, especially as there aren't really good options for that on the market which use FRC legal motors. So overall, the big advantage is weight if used for several functions. It helps reduce PDP port usage because the pneumatic control model that I have here plugs into the PCM port on the PDP. So it doesn't take up any of those valuable motor slots. Remember, you only have 16, 8 40 amp slots and 8 30 and 20 amp slots. It's also a great way to simplify programming, especially if you're new to robotics. Programming an arm to move between 2 positions can be very difficult. You might have to use limit switches an encoder, a potentiometer, or even current limiting to actually make the motor reliably stop at those endpoints. And they can be massive sources of failure. You can have encoders fail, limit switches break, and if you don't actually tune your current limiting correctly, you can also have motor failure as well. Pneumatics, on the other hand, will hold their position indefinitely and do not really wear in an FRC circumstance. They can also provide a very large amount of force in a small form factor. Look at this pancake pneumatic cylinder here. It might not look like a lot, but this will be giving out over 60 pounds of force in a very small package, which will be very difficult to do with a motor. There are some disadvantages, however, such as the very large base weight with the compressor, and especially if the new FRC rule mandating that teams must use the air compressor and not have an onboard the robot. Previously, you used to be able to use an offboard compressor and you could charge your tanks. We did that in 2018, but for 2019 and 2020, they are now using a onboard compressor, which means you must have this weight penalty. And this is about, I think, 3 or 4 pounds, which is a hefty amount of weight. Obviously, the system can fail and leak air. A few little leaks are okay and are to be expected if you're using pneumatics for the first time. But what can happen sometimes is a piece of tubing gets pulled out or the air compressor gets hit by another robot. And then you might find that the air is leaking out the system much faster than you can actually compress it. And that creates a lot of problems such as early disengaging of systems. But similar would happen with an electrical system. If your battery came unplugged, or if your power wire came out of your PDP or your robot disconnected, those similar things would happen. So although you have to think about and weigh up those risks, it's a fairly safe system with pneumatics. The air compressor also draws quite a lot of air from the battery. We do use the Norgan pressure switch, which basically means that the robot and the robot is told when the air needs to be compressed. So when it's less than 120 psi, I think, or 100 psi, the compressor will start. And that can be about a 10 amp, 15 amp current draw on the robot, which is actually difficult to control. For most teams, they wouldn't be able to turn that off or on during the match. Now we're going to cover some pneumatics terms. So PSI means pounds per square inch. So if we were able to calculate the area of this cylinder, so if this pneumatic cylinder here, this is a 32 millimeter bore, which approximately means that it's 1.25 inch diameter. So if we were then to calculate the area of the circle, the 1.25 inch diameter circle, then we would actually be able to multiply that by the PSI of the air going in, which is normally 60 PSI, to actually work out how many pounds of force this is going to put out. And as a general rule, we normally use imperial units, even though we're in Australia, because a lot of the parts and a lot of the rules in FIRST robotics are unfortunately in imperial units. And it can make things a little bit more straightforward to stay in PSI and CV and pounds. So now I'm going to be talking about CV. CV is essentially the flow rate through the the flow rate through the solenoid. So I'm going to show you several different solenoids, right? Here we have quite a small one. This is a SMC manifold solenoid we get from Vex. And then this is a Andymark solenoid here and another Andymark solenoid. And as you can see, there's a big difference in the size between these. The ports on this one are normally 5 millimeter. Ports on these ones are much larger. This is almost, I think, 1/2 inch NPT. And this one is, again, 5 millimeter. So although some of the ports might be a bit similar, the actual CV ratings, the flow ratings, can be very different. So it doesn't matter for most applications, but imagine if you wanted to bring a an elevator up very quickly, or you wanted to, if you've seen our 2018 robot, shoot one of the boxes high up into the goal. That would be important to consider the CV rating of the solenoid. But for most things, it's okay to stick with the standard ones available from AndyMark and Vex. So NPT is basically a measurement of threads per inch. So most of the pneumatics parts that you get in your kit will be a 1/4 inch or an 1/8 inch NPT, but there'll also be some which might be M5. It's based on the inner diameter of the port. So it can be quite difficult to see. So this one here is probably a 1/4 inch NPT, and you've seen here, this is probably 1/2 inch. So it can be quite difficult purely looking from the outside to understand what it is. So it takes a bit of learning and a bit of observation to actually be able to identify them, because it is a little bit tricky. Now, an actuator or a cylinder is a device that produces mechanical motion. And so that can be this small pneumatic cylinder here. It can be a small pancake cylinder. It can be this MAL series or TN series cylinder. It can be this really big pancake cylinder, or it can be this really big pneumatic cylinder here. Now we're going to talk about storage tanks. This is the storage tank most people use. It's a clipboard storage tank. The volume of this is 473 milliliters. And that's a fair amount of air. Normally, a couple of these, maybe 4, would be perfect for a normal pneumatic use in a robot. If you've seen some of our robots previously in 2018 and 2019, we use a larger aluminium tank because it could actually save some weight and actual pneumatics plumbing complexity over a lot of these individual ones. And you can also get smaller aluminium and steel ones. The tanks you choose aren't critical. Just make sure that they're appropriately rated, that they're legal for the competition, and that your robot has enough storage capacity to do all that you need during the match. Running the compressor all match to keep your pneumatics going isn't ideal. And also, you don't want to be in a situation where you need to be waiting on the field during the match for your compressor to charge. We've already talked about solenoids. There's a lot of different ones. This is a manifold solenoid. The advantage of a manifold solenoid is that you only have to have one input for the compressed air, and then you have each outlet per pneumatic cylinder. And that makes it a lot easier than having to use something like this AndyMark one or this one here, where each one has to be plumbed with an input and an output. Just 4 solenoids on this manifold alone would save 3 separate pneumatics tubes. And imagine that you'd then have to have a lot of other fittings, such as this 5-way or a T fitting to actually split up those flows. Now I'll talk about tubing briefly. 1/4 inch tubing is what we normally use. That's what will come in your kit. If you want, you can use 6mm tubing, which is a little bit smaller, but it can be hard to use the fittings from the kit then. It comes in a range of colors. You can also use 4mm and 532 tubing. You can also use, so you can use 532, you can use 1/4 inch, you can use 6mm, you can use 4mm. So there's a wide range of tubing options. The differences between these two, the size is mainly the flow rate. If you look, I can almost put the entire 532 or 4mm tube inside the 1/4 inch tube. So by going with 4mm, you definitely do lose some flow rate because you're actually losing the area, the flow area. But for a lot of applications, it's a great way to save weight. If you're doing an elevator, maybe you've seen our 2019 robot, we used this inside a cable chain because it's a bit more flexible. And it's a really nice way of improving your pneumatics if you don't need a lot of flow rate. If you're using a large cylinder, you definitely don't want to be in a situation where you're using this tubing. Other things, a fitting is a normal brass or plastic fitting. Normally, we'll be using threaded ones or a 1/4 inch push to connect fitting, or quick connect fitting as these can be called. They're really easy and nice to use. You can cut the tubing to length, you can push it in, and that creates a really solid airtight connection. And this allows really fast maintenance and replacement of items on your robot. And importantly, they're also much lighter than the steel, aluminium, or solid brass fittings that you would normally be using. Gauges, you have to have 2 on your pneumatic system, 1 connected directly to the air tank, and then 1 after the regulator. Here are 2 options. This is the one which comes in the kit. It's quite big. It has a brass fitting on it. We find that you can get these from Automation Direct. It's a lot smaller and it has the push to connect fittings. It's a good way to save weight and reduce complexity. Pressure switch is this part here. That's needed on the robot and you're not allowed to substitute this for anything. You must use the pressure switch that comes in the kit. We also have a basically like a relief valve here. Again, there's 2 options for this. You can either use the one which comes in the kit or you can use one from Mark. And also there are other options. You can use any pressure relief valve rated for 120 psi. Basically what this does is when the pressure is more than 120 psi, normally 125, 130 psi, the little spring inside will lift up and it will let that air pressure out, preventing dangerous circumstances such as the air tank exploding. The compressor is what generates the air. There's a couple of different legal options, and anything which is less than 1.1 CFM per minute, which basically means anything that will compress the air at a lower rate than 1 CFM per minute is currently legal. Obviously, we don't know about next season. And now I'm going to bring up the legal layout. So obviously we've got a lot of parts here and it might seem a bit of a mess, but this is what you need to work off. And I'm going to bring up a couple of layouts for you to see. And these are all normally available on, I think, the first Screen Steps website. And this is the layout that you need. There is some flexibility in here, but everything sort of needs to be in the same order. So for example, when we have a storage tank, we need to have a pressure relief valve almost directly connected to that. When we have the compressor, we need to have the pressure switch on the compressor or right next to it. We can't have the pressure relief valve or the pressure switch after the regulator. So we need to have the compressor, the air tank, and then we need to come to the regulator. This is the one which comes in the kit, the Norgan regulator with the gauge on it. And so you'd be having the air coming through down here and then out. A big thing with regulators is you need to pay attention to the arrow. And so on this one, there's an arrow on the right side. With a regulator, if it's in the wrong way round, the air will basically just vent out and it will create lots of problems for you. So make sure that your regulator is the correct way round. That can be a bit of a pitfall if you're using the smaller push to connect regulator. It's quite easy to put it the wrong way around, and that can create issues which are a bit difficult to diagnose if you're not familiar with pneumatics. And then you'd have a second gauge, and then after that you'd be able to have your air going to your range of pneumatic cylinders through your solenoid. This is another diagram. This is a little bit different. This is quite a streamlined way of doing it. If you are only having 1 or 2 functions, this would be a great way to actually plumb your pneumatics. If you see here, most of the fittings which are used are the push to connect fittings, which is a good way to save weight. And here's another diagram from team 5553. And it shows a pretty good layout and the difference between the lower working pressure and the storage pressure sides. So now I'm going to talk a little bit more about the components, and I'm going to show you, I'm going to talk about the components in more depth and show you some uses for pneumatics. All right. So the first thing we're going to talk about is we're going to be talking about the solenoids. Is this, okay. So this is what is called a manifold. I talked about it briefly before. And I talked about the reasons why it's beneficial. So essentially, you only have to have one input into it. So this manifold is a station manifold. You can get 1, 2, 3, 4, 5, 6 and upwards station manifolds. But it can be helpful if you need a lot of them to actually put two together. So it's a bit more versatile in future use. And I know Vex in Australia sell the 3, the 4, and the 5 and the 6 station manifold. And normally a 5 or a 6 station manifold is enough for a robot. So essentially you just have to have your one air line going in, and then you block this section off. So, right now we could block it off with a plug if we wanted. And then the air would be coming in here from our regulator, and then our air would be coming out of these to our solenoids and then to our pneumatic cylinders or actuators. And so these wires here are the actual solenoid cables which we need to plug into the pneumatics control module. So the pneumatics control module has a large number of ports which we need to use. So obviously we've got CAN. This connects to the rubber Rio, also the PDP, and if you're using CAN motor controls such as like Talanessa Rex or say like the Spark Max, that would plug in there. There's also one for the pressure switch. So you'd have your 2 wires and your pressure switch which plug in here. We have ferrules on this one, so it's pretty easy to push in. And with a pressure switch, remember it's a switch. It doesn't matter what polarity it is. So that's why you'll see that there's no, red or black on there. The switches, it doesn't actually matter which way round they go. Then we've got compressor out. For this one, it is important to have the polarity right. Make sure the black wire is going to the black and the red wire is going to the ground. It's the red into the red, so it has the correct, positive and negative. And then after that, we have the voltage input for the PCM. So in reality, this is quite similar to how you would be powering the VRM. It's quite a similar form factor. The main difference is that we're plugging in CAN as well. Something else to be careful of is this little tricky guy here. This can create a lot of problems for first-time pneumatics users. So by default, the PCM is set to 12 volts. And this little 3-pin jumper here, and this little thing that shows the positions. So if you're having issues with your solenoids not firing correctly, it may be that the jumper is in the wrong position. That is because the kit of parts and first choice solenoids, pneumatic solenoids, are normally 24 volts. So you want to check the data sheet, product data sheet, product page, to check the voltage that they are. It will normally be written as well, because if you've got this set on 12 volts rather than 24, your solenoids will not work correctly, and it will cause you a lot of headaches at competition. I know plenty of teams in Australia have made this little error, and then it causes a lot of inconvenience. So it's really good to check that. And this can be something, especially if you're helping other teams as well, this should be the first thing you check, because it's a super easy mistake to make. With these pins, there are 8. You could have up to 8 functions. on here. That would mean that you could have 8 solenoids potentially. And you can also have more if you need. I think you can have a second pneumatics control module if you need. And it's unlikely that you have them, but you can also use spike relays from the RoboRio relay ports to activate your solenoids as well. And these will work for single or double solenoids. If your pneumatic cylinders only need to go one way, then using a single solenoid, and you don't need to hold them in a position, and using a single solenoid will help you save PCM ports. If you're using a double solenoid because you need to hold the cylinder in a position once the robot is turned off, then you need to have that sacrifice of ports. So just keep that in mind because you'll normally only have one of these. But if you're using double solenoids, you can quickly eat up the ports. Imagine if you have 2 double solenoids or 4 double solenoids, that'll be all the ports gone. So keep that in mind. Again, you can have 2, so it's not a big deal. I'm going back to more components such as the air compressor. The air compressor is pretty standard. Majority of teams use the Via 90C air compressor. A couple of years ago, there was an Andymark one available, which is called the 1.1 pump. So that's an option as well. And so any air compressor which is less than 1.1 CFM of basically air compression or flow rate is allowed. Remember that needs to be at 12 volts. So if you're using something and you don't know if it's going to be allowed or not, make sure you check the manual closely, check the product page, and also make sure you bring some documentation to the competition because you'll need to be able to show the robot inspectors that your product that you're using on your robot is in fact legal. And so that can be difficult because some data sheets, especially for automotive applications, will be rated at say like 13.8 volts rather than 12 volts. Just need to keep that in mind. With this air compressor as well, air compressors get hot by the nature of how they work. The motor is a brush motor, it's not that efficient, but also the act of compressing the air isn't exactly a very efficient process either. So the actual compressor itself gets hot, so it can actually burn you. So you want to be careful with that. And also, if you've got this big metal and steel and brass piece along here, a lot of that heat from the actual compressor cylinder will get brought up along here. And so if you've got a piece of pneumatics tubing or pneumatics hose against here or actually plugged in here, eventually it might actually get hot enough for the pneumatics tubing to melt, deform, which isn't ideal. So it can be good to have a few fittings in front, such as this T-fitting here, pressure relief valve, the pressure switch, because those are fairly high mass. Brass has good conductivity, and it can help remove a lot of that heat and prevent the pneumatics tubing from melting. I mentioned earlier about the kit parts regulator. It uses 1/4 inch, I think 1/2 inch MPT fittings. And so once you factor in the weight of this, plus the fittings, plus the plug, it is quite a bit of weight. Currently, especially this year and previous years, there's a company in the US called Automation Direct, which sells this little system, this Nitrous System, which are really small push-to-connect pneumatics. So basically, this set here, gauge, regulator gauge, replaces all of these here, plus more fittings. So there's actually a lot of weight which is saved. It's space inside the robot, and it's actually easy to do. And we've actually found that push-to-connect fittings are generally a bit more reliable than threaded fittings, and a bit less open to leaks, especially if you've got inexperienced users doing the pneumatics. And so you can get these, they're fairly inexpensive. Automation Direct actually has a online voucher for first teams that you can use through the virtual kit of parts. Last year it was $25. So if you work together with some other teams, or if you do some sort of shipping forwarding to someone in the US, you can actually get these quite affordably. I think this system here would cost about $25 US after the voucher. And so it's a lot cheaper than having to buy buying the larger components, especially once you factor in the weight as well, and the other things that you might have to do on your robot to save weight. And it's a really good investment. You can use them multiple years. It's really, and they save space on the robot, and they're a good little nifty thing to have. So we really recommend that you have that if you can buy them. And again, there is the voucher available. Fittings, there are lots available. It's quite handy, but Vex Robotics down in Adelaide actually sell the fittings now as an option. But you can also get fittings from Andymark, a lot of other online suppliers, Automation Direct, the same place that you buy these. And you can get 1/4-inch fittings. 6mm fittings are a bit difficult to use because they don't match a lot of the other fittings that we might use in the competition. So for example, these manifold solenoids, the manifold is only available in 1/4-inch tubing. But a handy thing to know about using the 532 tubing is that 532 is so close to 4mm, it's 0.05mm different or something, that you can use a 532 tube and a 4mm fitting. So 4mm fittings are quite easy to get hold of in Australia, and they're cheaper than the alternatives. Buying the 1/4-inch fittings here. So that can be something to keep in mind because they're available both in the US and in Australia because of that 532 to 4mm compatibility. Pneumatic actuators, it can be quite daunting at first to build up a stock of pneumatic actuators because there's so many different choices. Obviously, if you only have this massive one, this isn't really practical to use for a lot of small applications in the robot. And the same way, if you only have this small one, it's quite difficult. So a good thing to do is to sort of work out the appropriate size that you need and then order it. So previously, Bimba in the US has offered a sort of like a cylinder donation program, but we don't normally make use of that because they take quite a long time these days. But there are plenty of places in Australia to buy the metric pneumatic cylinders. So rather than needing to build up a big stock, we recommend that the best way is to work out the appropriate size that you need and then order your cylinders. Or you can build up a small stock and then order extra ones. It's always nice to have a few cylinders on hand, but of course, normally you might need 1 or 2 cylinders of the same size, and that can get quite expensive. Now we can talk about pressure shutter. So in the air tank, you need to be able to release the air. That's a requirement in the first rules. And there's several different ways to do that. This one is what we used to use. It's nice, it's really easy to use, it's fun, but it's quite heavy. There's also other ones you can use like this, nice and easy. And also from the same range as the Nitro, a smaller version. Also, flow restrictors are quite handy. So flow restrictor is basically like, it doesn't function the same way as a regulator, but it's basically like a variable resistor essentially for air. So when I turn this screw, essentially the area inside is actually decreasing. It's making that cavity smaller. So if I have this cylinder here, and when I activate it, it goes out too fast or too violently, you can put a flow restrictor in line with it. And for a lot of cylinders, you can even get a flow restrictor which can actually be connected directly to the cylinder. So that can be a good way to reduce the speed of the cylinder moving without needing to use a separate regulator. And again, so here's one of the manifold solenoids from Vex or SMC. You can see how it works. There's no ports here. This fits directly onto the manifold. This is a large manifold, a large solenoid we bought in Australia, or it might have been from Animark. I think it was from Animark actually. And here's another Animark solenoid, and these ones do have the fittings on, so you can put a 5-motor fitting straight on like that, and then your air will come out the top, and you can put that to your cylinder. Now I'm going to talk briefly about cutting pneumatics tubing. So if you haven't used pneumatics tubing before, or you've just got the tubing in your kit, it can be quite easy to just grab a set of side cutters or a pair of scissors to cut the tubing. But it's very easy with these to accidentally cut at an angle. And what that will mean is that when you actually put that into your fitting, it won't create a proper seal, because I'm not sure if you can see, yeah, you probably can't see. But if you see those little silver bits inside, the push to connect fittings basically have little teeth inside, which are basically going to grip onto the pneumatics tubing. So it's important that you do a straight cut so that all those teeth can engage and make a proper seal. So normally you can use a pneumatics tubing cutter. When you buy things from Automation Direct using the voucher you get in the kit, such as these, you normally get a tube cutter. So to use this, you basically insert your tubing like that. So you press it down and you can cut like so. And that basically guarantees a nice straight cut. Whenever you're cutting tubing, even with one of these cutters, you want to be careful that you don't nick the tubing. So if I'm, say, putting this tubing in here, but I start cutting it, but I don't, and I move it, that's basically created a little notch on there, which is where a potential leak could start. So if you're having to disconnect something a lot, what would be an example? Say you're having to take your robot apart to go to the competition, or put it through a door, or put it in a shipping crate, or put it in a suitcase. Eventually, you might start getting leaks through your push to connect fittings if you're undoing, redoing, because again, inside here are little teeth which are actually gripping that. So what can be good is when you've disconnected a few times, to actually go ahead and cut them when it's off. And you'll see on the tubing where the actual little teeth have been digging in. So you might even be able to see here at the end, those little marks. That's basically where the little teeth in the push to connect fitting have been digging in. So it's a good idea to cut those off. And then we can start afresh and get no more leaks. These tools are available, fairly widely in Australia as well. But if you don't have one, again, just make sure that you try to do a really straight cut. You can do it with a good pair of snips like these, or a sharp, maybe like a pair of tin snips, something just going to mark the tubing. And if you double check and maybe do a bit of a leak test, that can work as well. But the proper tool is good, and it's a fairly cheap investment. I think they're either free or they're normally like $5 or something. Fittings which are good to keep in hand. We basically get like the divider boxes from Bunnings, the Tactics boxes, and we fill them up with the fittings that we want. And that means that we can easily sort of keep stock of what we have. Generally, the most useful ones are T's or splitters, and then threaded fittings. Things like, 90-degree fittings are useful, but they're not really that necessary. So if you can avoid, if you don't want to stock them, yeah, that's fine. But things like flow restrictors, T-fittings, plugs, general threaded fittings, that's the type of things that you want to keep on hand, because plugs especially allow you to quickly basically fix issues, or say you need to remove a mechanism during the competition. The plug will allow you to quickly pull that off, jam the plug in there, and not have to worry about the solenoid, not have to worry about any of the air leaking out. So now I might show or talk about some places that you can use the pneumatics on the robot. So if you've seen our 2019 robot, we use pneumatics a lot for very small functions. So for example, here, when we had the release of our climber, we had a pancake cylinder like this, because this can provide a lot of force in a small area, and you can use it almost pull out a pin. Something that would be quite difficult to use with a motor, especially to get something that small. And even a small pancake cylinder like this one could also pull out a pin. And a cylinder like this is about the same size as is normally used for shifting gearboxes as well. So they are going out of fashion a bit in first, but several years ago, shifting gearboxes used to be quite popular, and they would use pneumatic cylinders of about 3/4 inch or 20mm bore and 1/2 inch stroke to actually shift between the gears in a dog shifter or ball shifter style gearbox, and also for like a power takeoff style thing, because a pneumatic cylinder gives you quite a lot of force in a small package, and they're quite reliable as well. Obviously, the disadvantage for that is if your robot gets a leak, if it runs out of air, it was possible for basically the shifting gearbox to no longer work and to get stuck out of gear. But obviously, it's still a benefit over something using like a servo motor, which teams used to use, which would be quite slow and not have a lot of force. So it's always a trade-off. But pneumatics are quite good for applications where you need to pull or push small things. We would recommend not using pneumatics for a very big function. So something like an elevator, where you're having to move it a lot, means that you have to have a lot of air. And this cylinder alone, I think, is 1.5 or 1.75 inch, and it's got a lot of stroke. And so this cylinder alone would probably need one of these air tanks just to go out at once. And if you want to go in as well, that's another air tank. So the reality is, if you wanted to use a cylinder like this for an elevator or something, you would need a sort of an unreasonably large amount of air. And of course, because you have to charge the robot with the standard compressor, it would take 15 to 20 minutes to charge the air for one match. So pneumatics is really good for small applications and things, which small cylinders where you're moving things in and out. But if you've got a lot of volume, it can be better to look for things like motors, which can actually perform better in an application, like an elevator. Something like that would be actually better for a motor, even though there's obviously a cost of additional programming, lower reliability to just having to install a motor and wear. Pneumatics sort of reaches a point where there's just too much air needed for it to be practical. And we've got the 2018 robot down here to finish off with some robot functions. Do you want to move the camera around, or we can put on the table? I think we can put it on the table. Yeah. Just a little bit of time from the side. the other side. Yeah, so here we have the 2018 robot, just to finish off showing some functions. So on this robot, we use quality pneumatics, especially this top section here. So we have this pneumatic cylinder here on either side, which actually made these parts go out. And we also had a big pneumatic cylinder to go up and down. So I can quickly actuate that. So another handy trick is you can activate solenoids manually, even when the robot isn't powered, by clicking the switches that they have on them. So in this solenoid here, for example, the little green switch, if you push that from side to side using a little screwdriver, as so, it would actually activate. So I can do that now on this one here. I can in with a little screwdriver, and I can actually show some of the robot functions. We can also show the main activation as well. So for this one here, it's actually extending with the pneumatics and returning with this piece of surgical tubing here. And that is a way to reduce the air usage in the robot. So yeah, that finishes up the showing of this robot. And remember, there are always ways that you can use pneumatics positively and negatively. So you need to actually weigh those things up and think about the advantages and disadvantages. Again, on this robot, we used a large number of pneumatics. I think we had 6 or 7 functions or more. So it was quite a good way for us to reduce complexity and weight. But especially with new motors and things like the Talents Rex, so that you can do motion control and PID on board. If you're only needing to use a small number of functions, maybe 1 or 2 things, you have to weigh up whether it's worth it. But also, of course, pneumatics is an industry thing. It's used heavily in automation and factory use. So it can be a great way to introduce pneumatics at a basic level to students. So using some pneumatics on the robot can be a great way to, enhance your program, right? And to ensure that you're basically showing the students, a lot of what is to offer in industry, especially in automation. Yeah, do you want to finish off? And although I didn't do it right now, it is really important when you're testing your robot to wear safety glasses. So that's something we sometimes overlook. But again, wear your safety glasses when testing. It can be easy to get things going into your eye. Pneumatics is pressurized, remember, so we can have problems and you can get things thrown into your eye. So always remember to wear safety glasses and protective equipment when you're working. Yeah. All right. Thanks, everyone. We will now, I think, answer some questions from viewers.
Yes, excellent. So we do have some questions for you. The first question is, do you recommend that rookie teams use pneumatics in their first year?
It really depends on what their level of experience is. If they have maybe they have some mentors who have experience with pneumatics or have experience with first, then I'll definitely say yes. But normally I would recommend that, rookie teams, they try to go for a fairly simple robot approach anyway. So it might be that if they just want to make, a good example would be the gear, no, not the gear, the hatch last year. So pneumatics was a good example of something that was easy to use for that. So if they were using something like that, I would recommend that rookie teams use pneumatics for that, because it was in fact probably a little bit easier than using a motor. But I wouldn't recommend that teams jump in and use pneumatics for a large number of functions in the first year, because there are some pitfalls and mistakes that can be had related to, number of cylinders and air tank volume and things like that, and you can run into issues. But overall, I'd definitely say if you've got time during the off season to play around with it, I would definitely recommend that. But just make sure that you prioritize well during the season.
Okay, excellent. All right, the next question is, you showed some plugs in the unused solenoid ports. Are they purchased or were they 3D printed?
So you're not able to 3D print pneumatics parts. You need to have ones which are appropriately rated for 120 PSI to be legal in first. So no, we don't 3D print any of our parts. These, I think, are from Automation Direct. And I think maybe Vex Robotics sells them as well, but I'm not sure. But I think, yeah, from Automation Direct, I think these are. And so, yeah, no 3D printing of pneumatics parts.
Excellent. That's super good to know. Cool. All right. So the next question, the more flexible tubing for cable chain looks really useful. So where can we buy that tubing?
Okay, so this is 4mm tubing. So this was bought from an Australian supplier. So if you look up just 4mm pneumatics tubing, you can get that. If you want it to be flexible, you want to make sure that you're buying polyurethane tubing. So a lot of tubing is nylon. And that, of course, nylon is nice because it's chemical resistant and it's strong. But polyurethane tubing is a lot more flexible. Nylon tubing is quite stiff. So initially, when we actually wanted to convert our 2019 robot to the 4mm tubing, we accidentally bought nylon tubing because we frankly didn't know any better. And we thought that it'd be flexible enough. But when you actually look closely at the product specification, the data sheet, we found out that it was nylon. If you get polyurethane, it's really flexible like this. So yeah, you definitely want to get polyurethane over nylon. Otherwise, it's not much advantage over the actual normal quarter-inch tubing, which is nylon anyway.
Okay. All right. And so someone has also asked, what is the restriction of PSI in the actuators? And is it best to use pneumatics or motors on the intake?
So the restriction is 60 PSI currently, and of course this can change. So you're allowed up to 120 PSI in your air tank. But then after the regulator, the air can be no more than 60 PSI. So you need to make sure that you adjust your regulator and you adjust your relief valve before the competition to make sure that the relief valve is set to 120 PSI or 125 and that the regulator is set to 60. Because what you don't want to have happen is you don't want to be testing your robot not knowing that your regulator is set to 70 PSI or 80 PSI. Get to the competition, a robot inspector like me will say, oh, it's set too high, you need to change it. And then the robot doesn't work very well. That can be really disappointing. So yeah, check early that your regulator is set to 60. And that's just to even the playing field out. We don't want teams getting an unfair advantage, by being able to use a smaller, lighter pneumatic cylinder at a higher pressure.
Okay. And did that also address why it's best to use pneumatics or motors in your intakes?
If it's for rotating stuff, definitely motors. But for an intake which needs to go in and out, so say down to the floor and then back up again, I would recommend pneumatics, definitely. But only, again, if you're using it in multiple places. I probably wouldn't do pneumatics for one function because having a motor would necessitate probably having like a limit switch or a potentiometer encoder, or actually doing current limiting, which can be a little bit more difficult programming than simply having a off-on on a pneumatic cylinder. So it definitely simplifies the electronics and the programming using the pneumatic cylinder. So yeah, definitely go for a pneumatic cylinder for raising and lowering intake if you can.
Okay, excellent. All right. And the last question we have, the mini gauges and the regulator, is that a single item from Automation Direct or 3 separate parts?
Okay, I'll try. Maybe I can put a comment on that onto the product page in the comments after this is finished. But basically, here's the gauge, and then here's the regulator, and they also sell the little tubing which connects them all. So this is a special molded tubing which is molded into that really tight radius because the standard tubing simply can't bend to be that tight. So there's a special tubing from them, and that simply plugs in the gauges, and it's really nice and simple. And they also sell the shut-off valve as well. It's a really good way of saving weight. I think a team might have weighed it. I think we save like nearly a pound, I think, removing a lot of these fittings and going to this. And also it's a lot more compact and it's much easier to use as well.
Excellent. All right, Alistair, thank you so much. This has been quite interesting for me from a standpoint of a non-robotics person, the fact that I don't actually build robots. So it's quite interesting. It was very informative. And we want to thank you so much for coming on with us tonight. And also to Diane from Barker as well. We know she's been behind the camera and working the PowerPoint and handing you tools and parts and stuff. So thank you so much for that. And also I want to thank Ian Jessett down in South Australia. He has been manning our chat room in YouTube and sending us the questions through. So thank you so much. Have a wonderful night. Yeah, thanks.
So if anyone has any other questions, I'll keep an eye on maybe on the comments on the YouTube, and I can try to answer them in the comments. Yeah, that's probably the easiest way if people want other questions answered.
Yeah, fantastic. That would be awesome. Thanks so much. And don't forget the Facebook page as well. So want to direct you.
Oh, great. Perfect.
Yeah, for Australia.
Yeah, thanks for having us.
Competition Facebook page, and Alistair will hop on there and answer any questions that you may have as well. All right, thanks and good night. Everybody have a great night. Thank you. Thanks. Bye-bye. All right.